Hello students, good morning. Now we can see Fourier Transform. What is meant by Fourier Transform? It is mathematical transformation employed to transform signals between time domain and frequency domain. Time domain is denoted by x of t and frequency domain is denoted by x of j omega. Fourier transform does not exist for all type of signals. Fourier transform does not converge. Fourier transform is applicable for both periodic and aperiodic signal. So the Fourier transform is defined in two ways. One is f of x of t is equal to x of j omega is equal to integral minus infinite to plus infinite x of t e power minus j omega t into dt. So the relationship between Fourier transform and Laplace transform is x of s is equal to s is replaced by j omega, you will get x of j omega. Inverse Fourier transform is defined as x of t equal to 1 by 2 pi integral minus infinite to plus infinite x of j omega e power j omega t d omega. So equation 1 and 2 are called Fourier transform pair. So the first equation is known as analysis equation. The second equation is known as synthesis equation. So existence of Fourier transform is nothing but the Dirichlet conditions. So what is meant by Dirichlet conditions? The signal x of t should be absolutely integrable over the range of time period. Integral t naught, this is fundamental time period, modulus x of t dt is less than infinity. Any signal x of t, sinusoidal, exponential, step, okay, and unit step, whatever may be, if you integrate it, it must give finite value. That is called absolutely integrable. The signal x of t should have finite number of maxima and minima over the range of time period. You take a time period, okay, it has finite number of maxima and minimum. Okay, the signal, for example, for this case, if you draw a signal, okay, so it has a period of time, okay, so this is maximum, this is minimum, okay, it has finite number of maximum and minimum over the time period. So from here to here is the time period. Now the signal x of t should have finite number of discontinuities over the range of period. So the finite number of discontinuity is nothing but this one. Okay, if you are getting like this, no, this is discontinuity over the range of time period. So if this condition is satisfied, then we can have the Fourier transform for any type of signals. Now frequency spectrum using Fourier transform or Fourier spectra. The x of j omega is a complex function of omega, hence it can be expressed as x of j omega is equal to x real part of j omega plus j x imaginary part of j omega. So xr of j omega is real part, xi of omega is imaginary part of x of j omega. So we have to calculate what is the magnitude. So the magnitude spectrum is modulus x of j omega is equal to square root of real part square plus imaginary part squared. So the phase spectrum is angle of x of j omega is equal to tan inverse of x imaginary part of j omega divided by x real part of j omega. So the magnitude and phase spectrum is known as frequency spectrum. Now we can see the relationship between Laplace transform and Fourier transform. So all of you know very well that the Laplace transform formula x of s is equal to integral minus infinite to plus infinite x of t e power minus st into dt. If you substitute s is equal to j omega in equation 1, we get the Fourier transform. Okay. Similarly, you take the inverse Laplace transform x of t equal to 1 divided by 2 by j, the integral sigma minus j infinity to sigma plus j infinity x of s e power st into ds. Here, wherever s is present, substitute j omega to find the inverse Fourier transform. So, you will get this s can be replaced by j omega, this s can be replaced by j omega, this s is replaced by j omega. So this j, you bring it out, both get cancelled, you will get the equation. So this is the relationship between Laplace and the Fourier transform. Okay, now we can see properties of the Fourier transform. So the property is listed here. This is what are all the aperiodic signal x of t is listed here in second column. The third column is Fourier transform for the corresponding signal. So the linearity property is a1 x1 of t plus a2 x2 of t. The corresponding Fourier transform is a1 x1 of j omega plus a2 x2 of j omega. Then the time shifting property x of t minus t naught e power minus j omega t naught x of j omega. Time scaling x of a t, a is the scaling factor, 1 by modulus of a x of j omega by a. Time reversal x of minus t, x of minus j omega. Frequency shifting e power j omega naught t x of t, okay, this is equal to x of j minus omega naught. Differentiation in time domain d by dt into x of t, j omega x of j omega. Differentiation in frequency domain, t into x of t is nothing but j dx of j omega divided by d omega. Convolution theorem, x1 of t convoluted x2 of t is nothing but the product of x1 of j omega x2 of j omega. Parseval's theorem, integral minus infinite to plus infinite modulus x of t the whole squared into dt is equal to 1 by 2 pi integral minus infinite to plus infinite modulus x of j omega the whole square d omega. Conjugation, x conjugate of t is Fourier transform as x conjugate of j omega. So these are all the properties of Fourier transform. Now we can see the problems, how to solve the problems. Okay, Fourier transform problems. Find the Fourier transform of x of t equal to a e power minus at u of t. First you write down the formula Fourier transform as we discussed in the previous slide. Okay, here the x of t is given in the problem. Okay, you substitute it, a e power minus at into ut. Okay, integrate it, substitute the lower limit and upper limit, we will get the answer is x of j omega is nothing but a divided by a plus j omega. So from this you take the conjugate part, you multiply in the numerator and the denominator. From this you find what is the real term and the imaginary term. Calculate the magnitude spectrum and the phase spectrum. Okay, for these two, each and every value of omega, you plot the graph. So this is the what input is given, this is the magnitude response for the given signal, this is the angle of the given signal. Now we go to second problem. Find the Fourier transform of x of t is equal to a e power minus a modulus of t for all t. So modulus of t is nothing but if t is positive, okay, if t is positive, what you will get, positive values of t 0 to infinity, you will get this term. If t is negative, the amplitude, the power becomes positive. So this is the limit minus infinite to 0. Okay. So now you write down the formula of Fourier transform. Okay. Then depending upon the limit, you substitute it. minus infinite to 0, the signal is a e power at, put it here, e power minus j omega t dt. Similarly for the other case, now you integrate it, substitute the lower limit and upper limit. Okay, after obtaining this, you will get the final answer, this one. You calculate the magnitude response and the phase. Okay, the magnitude response, you will get this result. Different values of omega, plot the response, you will get the magnitude response. Similarly, the phase spectrum 0, it is marked here. Now we can see the next problem. Find the Fourier transform of x of t equal to 1 for minus t2 plus t. Okay, write down the formula. What is the amplitude here? 1. The signal is drawn here. Minus t2 plus t, the amplitude becomes 1. This is graphical representation. This is mathematical representation. Okay, write down the formula for Fourier transform. Okay, what is the limit? Minus t2 plus t, what will be the amplitude is 1. Okay, now you integrate it, substitute the upper limit and the lower limit, you will get the equation is like this. Okay, now you have, this can be written as 2 sine omega t divided by omega. Okay, this can be written as sine theta by theta is nothing but sin theta. As per this equation can be written as sin form. Okay. So this is about the Fourier transform for the rectangular pulse. Now we can see the problems under inverse Fourier transform. Determine the inverse Fourier transform of the function. X of j omega is given. The limit omega is minus omega to plus omega. Okay. Now all of you know that the inverse Fourier transform formula, this one. X of t equal to 1 by 2 pi integral minus infinite to plus infinite x of j omega e power j omega t d omega. Now you substitute the limit minus omega to plus omega. What will be the amplitude given here is 1. Substitute it here, integrate it, substitute upper limit and the lower limit. Now you will get the answer x of t. Okay, so if this is can be written as a trigonometric formula. Now sin omega t by omega t can be written as zinc wt. Okay, so this is the inverse Fourier transform. Now we can see, determine the convolution of x1 of t equal to e power minus 2t u of t and x2 of t is e power minus 6t u of t. Okay, this is by applying the convolution property, we have to solve this. Okay, this is, you take the convolution property says that is x1 of t convoluted x2 of t is equal to the product of their transforms x1 of j omega, x2 of j omega. For the first signal, okay, calculate, the first signal is here, calculate the Fourier transform. So you know that 1 divided by j omega plus 2. Okay, the Laplace transform for this is 1 divided by s plus 2. I told you the s can be replaced by j omega, you will get this. Similarly, this is second signal. Okay, if you take the Fourier transform, you will get 1 divided by j omega plus 6. Directly, you multiply x1 of omega, x2 of j omega as the property says. You will get this one. Now you do the partial fraction. Find the constants a and b. Okay, you will get it like this. X of j omega equal to a is 0.25, b is minus 0.25. Substitute it here. Now you take inverse Fourier transform. Okay, we will get the final result is this one. Okay, this convolution we have using graphically we can solve it, or by using the Fourier transform. Okay, so which one is easy for you? You can apply that method. Thank you for listening.